solving a system of equations by using substitution. This is another method in addition to the graphing. This is my least favorite of all the methods we're going to be looking at, but it's one that somebody considers important, so we will do. Now, what we need in order to use substitution is we need one of our equations, at least one of our equations, to be one we can easily solve for one of the variables, meaning we can rearrange it so it says either x equals stuff or y equals stuff. And in this case, both of them actually are very easy to rearrange because there's no number in front of the x. I'm going to choose the second one, and I'm going to rearrange it so that it says x equals 4 plus y. Just add y to both sides. Now remember, this is a system of equations. We want both of them to be true. So for this one to be true, whatever y is, x has to be y plus 4. Well, if that has to be the case, then why not replace this x with y plus 4 or 4 plus y? So we're going to take this equation and we're going to replace the x. Right, we have x minus 2y equals 7. We're going to replace the x with this here because x is equal to 4 plus y. And that gives us a new equation to solve. We have 4 plus y minus 2y equals 7. So 4 plus y minus 2y is minus y equals 7. Subtract 4 from both sides, we get negative y equals 3. Multiply by negative 1, we get y equals negative 3. Right? So that's one of our numbers. That's our y coordinate. To get our x coordinate, we want to take the number we just found and put it into this equation that we found in step 1. So we're going to pop the negative 3 in there for y, and we will get x is equal to 4 plus negative 3, which is 4 minus 3, which is 1. Right? So our solution to this system is going to be 1 comma negative 3. If we put a 1 in for x, minus 2 times negative 3, that would be plus 6. That gives us 7. And 1 minus a negative 3 is 1 plus 3. That would give us 4. All right, let's do one more of those. Got a system x plus y is 9, and 2x minus 3y is negative 2. Both of these have a number in front of them. They have a coefficient. Here, neither one does. So I'm going to rearrange this one this time to be y equals 9 minus x, right? Subtracting x from both sides. And then I'm going to replace in the other equation, right? I've got 2x minus 3y equals negative 2. I'm going to replace the y with the thing that it's equal to, with our 9 minus x. This gives us an equation with one variable to solve. It's going to be minus 27 plus 3x equals negative 2. So that's 5x minus 27 equals negative 2. Add 27 to both sides, we get 5x equals 25. So of course, we know x is equal to 5. So that's our x coordinate this time, 5. We need to find our y coordinate, so we put this into that equation there, and we get y is equal to 9 minus 5. So of course, y is equal to 4. And you can double check. 5 plus 4 would be equal to 9. That's true. 2 times 5 is 10. 3 times 4 is 12. 10 minus 12 will give us the negative 2. So check. And that's it for the substitution method. Remember, it's best used when one of your equations is easy to solve for either x or y. So if this was like 5x plus 7y and this was 2x minus 3y, I wouldn't use the substitution method here. It would be too ugly. See you next time.